This is the OpenHPI course Linked Data Engineering, Lecture 1, Linked Data and the Web of Data. This is the second part in which we will talk about what does it mean to understand data on the web. We have already talked about that, for example, for search engines, it's rather important to understand the content of the information, of the data which is stored in the web to get correct results for the user back. So, what does it mean to understand data on the web? First, let's have a look at the web of data. So this is a picture that we will see rather often in this course. So this is the linked data cloud, the so-called web of data. And this is a huge set of data sets which are interconnected with each other via links. But the point is, of course, so where do these links between these different data sets come from? So who is responsible for mapping one data set to the other, and how does this work? And of course, if there is a link, what does this link mean? Are all links the same kind of links? Do they have different meanings? How should I act with this data if I don't understand what's in a link and what's the meaning of the data behind? So this is quite difficult. So therefore, we will take care of what does it mean to understand something. So how does this work? How does this function? So first, let's have a look at meaning and comprehension. Of course, the rather important topics if we want to make sense of understanding. So first, understanding, it's defined as the ability to grasp the meaning of information, the semantics of information. So this is understanding. If I understand something correctly, I correctly interpret the meaning of the information. And then information usually is conveyed in a message from a sender to a receiver. And when I do this, when I convey a message, I use a specific language in which this information is expressed. And I can only understand this information, so the information can only be understood by the receiver of a message, if the receiver interprets the information correctly. If the interpretation is wrong, the information is not understood and the receiver does not receive the correct message or understand the correct message. So these are rather important notions for the process of understanding. How does successful communication happen? How does this work? So what do I need for successful communication? First, the information has to be correctly transmitted. And so I have to take care to form correct sentences or correct messages. With this, I guarantee with the help of syntax, which defines rules of how to create correct sentences, correct messages. So first, correct transmission of information. Then, of course, the meaning, the semantics of the transmitted information must be interpreted correctly. So the meaning must be understood. The information must be understood. Otherwise, it's not a successful communication. So, what does the understanding now depend on? First, on the context. Because the very same message in different contexts can be interpreted in different ways. So it means in a different context for sender and receiver, the same message of both can be interpreted in a different way, and this means then they don't understand each other because they have wrong assumptions. They assume the wrong context. So context is a rather important notion. Nevertheless, then also the next stage is important, which is the pragmatics of the sender, for example. So the sender has a specific intention with his message. So therefore this, which is called pragmatics, also influences on how the information is interpreted by the receiver, because the receiver assumes a specific pragmatics of the sender. So only if all these assumptions somehow go together, they map together, then understanding only becomes possible. Let's have a look at the context again, which is the context dependent on. So the context of sender and receiver depends on usually their history, which means their experience, which is nothing else but the knowledge of the world they both have, sender and receiver. Only if they have a common subset of their experience, then they will be able to understand each other. So these are really important notions for the process of understanding in theory. Let's look at some examples in practice. So how does communication of meaning really work? This has been already researched for quite a long time, and probably you are familiar with the work of Ogden Ridges and this so-called semiotic triangle. So they have researched what does it mean if I try to convey a message expressed in symbols, and how does this process of communication and understanding really work. So let's imagine we have a message which says Jaguar. So usually then you would think of a cat, or maybe a car, or maybe of this operation system. The question is only which of them do you mean? So you can't make it out only of this one single word. What you need to distinguish what is really meant, you need context, you need more information, more words to make sense of it. But usually what we want to emphasize here is first this symbol or this string of symbols usually stands for an object in the real world. So for each object in the real world, we have a symbol or a string of symbols which represents it. And usually if you hear that symbol, in your mind, something like a concept pops up. And then you think, this object in the real world is referred by that. But it means this symbol symbolizes this kind of concept which refers to an object in the real world. And now you have this kind of triangle. And what you want to convey in a message from a sender to a receiver is a specific concept. Only if the same concept is understood or received from both, so if the sender has the same concept in mind as the receiver, then they can really both make the same sense or the same meaning out of the same symbols that are sent as a message. Only then successful communication is possible. So this is the essence of this process of understanding by Ogden Ridges, and this dates back to 1923. And we will come back to that several times in the course of this lecture. And of course, successful communication then depends on the context, on pragmatics, and on experience, as we have already said. Okay, let's get back to some examples. We try to understand data on the web. This is a very nice example. This is a dwarf planet, Pluto. You might have heard of it. And the point is, just let's try to imagine you find this text on the web, Pluto, and then you have to make sense of it. What does it mean? And as we have already said, natural language is full of ambiguities, which means we have somehow to solve these linguistic ambiguities with a process which is called disambiguation. So it means that the text Pluto can stand for an entity, for example, for the Disney cartoon character, for this dog, you might know that. Or it might stand for a Roman god, so the god of the underworld in Roman mythology. Or it can be a song title, a song by the Iceland singer Björk. Or of course it can be a ship, HMS Pluto is a ship, and of course it can also mean a dwarf planet. The process to decide which of these entities is really meant by that string of symbols, this is called entity mapping or entity linking or disambiguation. And this will also be one of the tasks we will later do in this course. In an automated way, of course. Okay, now we have this mapping. We have a string of symbols, which is Pluto. This is mapped to a semantic entity. But how to make sense of a semantic entity? And here the nice thing is we must somehow explain what is Pluto, what is it? So usually you do this, that you say, okay, we must define the meaning explicitly. And this can be, for example, be done that we say, okay, this entity belongs to a class. We call this class dwarf planets. And in this class is a set of entities which all share similar properties. This makes out a class. So in a dwarf planet, there will be probably then other dwarf planets. So what is a dwarf planet? It's of course also defined by its entities. And we look at the, for example, at the properties of these entities. But we can also say, okay, this class is part of another class in some kind of a hierarchy. So we can say dwarf planet might be a subclass of planets. So every dwarf planet might also be something like a planet. But this, of course, is also open to interpretation, but you could define meaning in a way like that. And then you have something like a class hierarchy, which gives you, again, some interesting notions and interesting information about the meaning of this text, Pluto. But it's not only about classes, it's even more. So what you can do already if you have class memberships is, if you define these classes with a proper knowledge representation, like a formal ontology, you will be able to make logical deductions. So how does this work? Simple example, we have here Pluto, our entity, which belongs to several classes here in this box. So we say Pluto is a natural object, Pluto is an astronomical object discovered in 1930, it's also a celestial body, and it was in a class which was called minor planets, to be visited by a spacecraft. Interestingly, this last class, minor planets to be visited by a spacecraft, is a subclass of dwarf planets, which is a subclass of planet. So, what kind of implicit knowledge can I deduce from this interesting knowledge representation? What I can do is quite simple. By a logical inference, I can say, okay, Pluto must also be a dwarf planet, simply because Pluto is in the class minor planets to be visited by a spacecraft, and this is a subclass of dwarf planets, so therefore Pluto is also a dwarf planet. Moreover, I know that a dwarf planet is or might be a subclass of a planet. Then I can deduce in the same way that Pluto is also a planet, which might now be a little bit confusing, simply because Pluto has not the status of a planet, it's a dwarf planet, but this is only, let's say, some structural hierarchy, not necessarily what people define what a planet is and what a dwarf planet is. Okay. But the point that I wanted to make clear is, in these constructs there is hidden information which can be made explicit with the help of logical inference. But this is only possible if for the representation a formal knowledge representation is used, where you have a formal logic as a foundation on which the logical inference is based on, because all your inferences, of course, they must be correct and they must be complete. You only can guarantee this if you have a formalism behind that, and this is guaranteed usually by the use of formal ontologies. Okay, what else can I express in a formal knowledge representation? It can help me to understand what is on the web. We said Pluto is an entity, and for that it belongs to a class, and in these classes usually entities with the same properties somehow are gathered. So, for example, a planet can have several properties. It can have a name, it can have a radius. For example, there can be a date available when the planet has been discovered, and also who has discovered this planet. These are so-called properties, and properties are usually defined by defining a domain and a range for a property. So, for example, for the name, you can say the domain is a planet, and the range then is a character string. So, which means the name is expressed as a character string for a planet, or the radius is expressed as an integer number for a planet, or the discovery date of a planet is expressed as a date or time, or the discoverer of a planet usually is a person. So this is the way how you can represent things like that. You simply define properties and you restrict domain and range of these properties to see how this knowledge is connected and what kind of restrictions and constraints are defined. And usually with the help of this network that is created here of constraints, of interactions, knowledge is represented, knowledge is expressed. And in the end of it, what comes out of it, if you put knowledge like that on the web, you will end up in something like the semantic web, which is also the web of data. So what is the semantic web? In the semantic web, the meaning of information is made explicit by formal, which means structured, and standardized knowledge representations, which are ontologies. The nice thing then is that it will be possible to process the meaning of the information in an automated way. So machines will be able to access and to process this information automatically. And it will also be, machines will be able to relate and integrate heterogeneous data without the interaction or necessary interaction of the user. And what we have seen just now is we can be able to deduce implicit, so this means not evident information from existing evident information, also in an automated way. Some people say the semantic web is a kind of a global database that contains a universal network of semantic propositions. You can also say it's the web upgraded by explicit semantics. So the notion is quite old, so there was already in Popular Science here in Scientific American an article about the semantic web in 2001 by Tim Berners-Lee, James Handler and Ora Lassila. And there they defined the semantic web as an extension of the current web in which information is given a well-defined meaning. So this means explicit semantic. And the purpose was to better enabling computers and people to work in cooperation. So there is a link to this article, so maybe you are interested in it, and then you get a notion about the semantic web. Okay, how do we continue? We will have a look at the building blocks of the semantic web, and one of the building blocks is the so-called resource description framework. So we want to express knowledge, we want to represent knowledge, and for this we need something like a universal knowledge or universal data representation, and we try to make as a foundation or use as a foundation the so-called resource description framework. And we will do this in the part number 3 of this lecture.